really consistent and inconsistent. But there is one thing you do have to know. First of all, a system of equations is more than one equation, right? And we're going to be working with two equations. And we're working with linear equations, so we're working with two lines. And there's three different scenarios, so to speak, or situations when I draw two lines on a graph. Okay, I can draw two lines on a graph and have them intersect. Well, let me get my highlighter out. Okay, there's two lines on a graph and they're intersecting. The solution to my systems of equations for this particular example would be exactly 1 point, because they intersect here at 1 point. So my first scenario is that I have exactly one solution. Now remember what a point is, right? It's an x-coordinate and a y-coordinate, or an ordered pair. So please put your answers in ordered pair form. That's a point. Now, the second situation. If I have a line on a graph, there's my line, and what if I take another line and put it right on top of that line? How many points in common do they have? Where do they intersect? Huh? Yeah, infinitely many, because, you know, lines go on for infinite. So every point on this line they intersect, so there's infinitely many solutions. Now, if you don't write down infinitely many solutions or infinite solutions, you get the answer wrong on your quiz or test. Even though you could have done a whole ton of algebra work to get to that point, if you don't write down infinitely many solutions, you get at least half a point taken off for the problem. Please don't make that mistake. Now, what if the only other situation I have here is if I have two lines on a graph, where do these intersect? They don't. Okay, they're parallel lines. If you get into a situation where you have no points in common or they don't intersect, you have to write down no solution for your answer. So from this point on, for the next 2 or 3 weeks, however long it takes us to get through Unit 6, you're going to write down either an ordered pair, or you're going to put down infinitely many solutions, or no solutions. One of those three. If you don't, you're going to get half a point taken off. Okay? It's got to be one of those three. Like I said, don't worry so much about the consistent, independent, dependent, inconsistent. You're not going to look at that until probably after high school math. Questions, comments, or concerns? Okay, there's a lot of different ways that we can find whether two linear equations, a system, is one of those three scenarios. Okay, the first way or method that we're going to learn is the graphing method. And that's why I had you guys work with so many lines and slope and all that other stuff for the past couple of days, because that's what we're going to do. We're going to graph each line and see which scenario they fall into. Unfortunately, the graph here, did your graph not come out too well here? Yeah, so we're going to have to estimate here. Okay, let's do an example or two, and then we'll take a look at your homework. All right. So here's my system. I'm going to rewrite these. Again, it looks pretty light. So here's my system of equations. I have x minus y equals 2. Let's do 2b. I don't even like that one. Let's do the other one first. Okay, so 2b, I have y equals negative 2x minus 3. And then I have 6x plus 3y equals negative 9. Okay, the first one, y equals negative 2x minus 3. I can easily graph that because it's in, yeah, y equals mx plus b form, slope-intercept form. What's my b? Negative 3. Good. What's my slope? And we just did a whole bunch of these, right? So again, we're going to have to estimate here. I can just barely see my graph here, but let's see what we can do. So negative 3 is where it crosses the x or y-axis. So negative 1, negative 2, negative 3. And you could either put that minus sign with the 2 or you could put it with the 1. I'm going to put it with the 1. So I'm going to go up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. Okay, so there's my line. There's my first one. I might even put a couple of more points on there. I'm going to go down 2 to the right 1, down 2 to the right 1. There's my first line. And again, this is where you're going to have to use a straight edge. So if you need a ruler or something, they're up here. There's my first linear equation in the problem. Now, my second one. What do I have to do before I even graph this line? Have to put it in slope-intercept form first, right? Okay. So I'm going to subtract 6x from each side. These add up to 0. Going to bring my 3y down. That equals, I'm going to put my x term first, negative 6x minus 9. Not done yet. Divide every term by the coefficient 3. Okay. 3's cancel the 1. 1 times y is my y. Negative 6 divided by 3. Good. The x is in the numerator, so we'll leave it, pull it out, whatever, however you want to think about it. Negative 9 divided by positive 3. Negative 3. Good. So for this line, what's my y-intercept? Negative 3. My slope? If I notice here, my slopes are the same, right? If you've had a little bit of geometry before, if my slopes are the same, what kind of lines do I have? Anybody in geometry? Oh, parallel lines. These are going to be parallel lines. Okay, same slope are parallel lines. Let's graph it anyway. Well, look at that, negative 3. It's the same. Oh, by the way, It's not just parallel lines, it's what? It's the same line, isn't it? Up 2 to the left 1, up 2 to the left 1, down 2 to the right 1. So it's the same line, not parallel lines. So what's my answer for this problem? Infinitely many solutions. Now you can abbreviate it. See, we can abbreviate it INF for infinitely many, and we can abbreviate solutions SOLN. So that's my infinitely many solutions answer. Let's look at your homework sheet. So, by the way, that's called solving systems of equations by graphing method. Okay. Then I gave you a homework worksheet. In fact, you got 2 of them. I haven't passed out the second one yet. All right, let's look at a couple of these, because a couple of these are kind of tricky. Let's look at number 1. First thing I'm going to do is graph this line. Y equals 3x. Okay, so I need my y-intercept, and I need my slope. What's my y-intercept here? Here, give it to Mr. Chambers, see if he can figure it out for you. Well, let me ask you this. The slope is easy to get, right? What's my slope? It's the coefficient of x, 3 or 3 over 1, right? Now the y-intercept, even though it's not there, we are adding something to this. What, Brett? 0, yeah. We are adding 0 to this. So my y-intercept is 0. So I'm going to go ahead and graph that line. Crosses my y-axis at 0. I'm going to go up 3, 1, 2, 3, to the right 1, up 3, to the right 1, up 3, to the right 1. I could actually go down 3 to the left 1 also. Down 3 to the left 1. See how my line continues? Make myself a nice perfect line because I have OCD about it. And there's that equation. Now, my next equation. What's my y-intercept? What am I adding to this? 0. What's my slope? Okay, so again, I'm crossing at 0. I'm going to go up 1 to the right 3. Up 1 to the right 3. 1 to the right 3. Draw my line. And where do these two lines intersect? Yeah, at the origin here, 0, 0. That's my solution. How about number 2? Let's graph this line. It's one of those horizontal, vertical things, right? Do I remember which one it is? Which one is it? Horizontal or vertical? Huh? Vertical. Now remember, every x value is -5. So here's a -5 for my x. That's where we start. No matter what my y value is, x, oh, I'm sorry, -5. My fault. -5. No matter what y value is, x is always going to be -5. Okay, it's a vertical line. So there's x equals -5. Okay, let's graph the second one. What's my y-intercept? -3. What's my slope? Yeah, there's a coefficient of 1 here, so it's 1/1. Okay, so crosses my y-axis at -3. And I'm going to go up 1 to the right 1, up 1 to the right 1. And actually, I could go down 1 to the left 1. That's the same fraction. Down 1 to the left 1. If I keep going here, I'm going to hit that line at a point, right? Right there. So my point of intersection is going to be -5, -8, yep. Some teachers don't even care if you put the line there, only the dots, the points. Number 6, you can do it without graphing, can't you? If I have one vertical line and one horizontal line, they're going to intersect, right? This is a vertical line. That's a horizontal line. My x value is always going to be what? 4. My y value is always going to be, here's my point of intersection. Don't believe me, graph them. I think the only other tricky one is number 3. What's my y-intercept? What am I adding to this? 0. What's my slope? There's a 1 in front of that x. I have -1/1, right? 0, -1 to the right 1, down 1 to the right 1, right 1. There's that line. Graph the other line. Y-intercept is slope. So let's see, 4, go up 3, right 1. Actually, probably easier to do -3 over -1. Down 3, 1. That's my point of intersection right there. It's going to be -1, 2. Actually, I counted wrong, didn't I? -1, 1. Did I give you enough examples to do the rest of the worksheet? Oh, you got a puzzle too. Number 10, you're going to have to do what? You're going to have to put them in slope-intercept form first. Y equals mx plus b. Okay? Questions, comments, concerns? You guys know what you're supposed to do now? Wonderful. You've got like almost 20 minutes, if not the whole 20 minutes, to do this worksheet.